Hi everyone, our today's topic is redox equilibria. We're going to start off with the very basics and we're going to look into the difference between oxidation and reduction. I'm sure you all must be having some idea. So let's start off. Oxidation, as it's evident from the name itself, it means addition of oxygen, as in you're adding oxygen to something. Now, the other meanings for this could be removal of hydrogen or removal of electrons. Now, there's a really cool mnemonic which is pretty common, and that is oil rig. You can use this to remember these 2 points. That oxidation is basically loss of electrons, and oxidation is loss of hydrogen. So O stands for oxidation, I stands for is, L stands for loss. So oxidation is loss of electrons, oxidation is loss of hydrogen. And as it's evident from the name itself, oxidation is addition of oxygen. So basically everything is being lost, the only thing that's being added is oxygen. So it's very easy. Oil, loss of electrons, loss of hydrogen, and addition of oxidation from the name itself. Since you're adding oxygen, it means there's an addition of electropositive element, electronegative element. So the opposite is going to be removal of electropositive element. You're adding electronegative element. Oxygen is electronegative element, so you'll be removing electropositive element. And oxidation, again, as it's evident from the name itself, that you're increasing the oxidation number. Now, when we come at reduction, so it's basically just the opposite. As the name says, removing oxygen. So that's okay. Now, rig. Rig means reduction is gain of electrons. Fine. Reduction is gain of hydrogen. And reduction is removal of oxygen, that we know. So we have learned this. Sorry, removal of oxygen, that we know. So we've learned this. And we know reduction is gain of hydrogen, reduction is gain of electrons. So we've learned this as well. Now, since you're removing oxygen, it means you're removing electronegative element. So you'll be adding electropositive element. So we have learned this as well. And reduction means decrease of oxidation number. So we've looked at the basic differences. Now moving on. Now there's some oxidation numbers that you're required to learn. And I'm sure you already know a lot of them. There can be some confusing ones, so we're just going to be looking over those. The first one being hydrogen. Now hydrogen has two possible oxidation numbers. Let me just jot it down here for you. So I'm a perfectionist, I need this to be as tidy for you all as possible. Yep, here. So hydrogen has two possible oxidation numbers. One is -1, one is +1. Now, -1 is basically when hydrogen is attached with metals, and +1 is when hydrogen is attached with non-metals. I'll just give you examples and make it understandable for you. So, example for the first thing is gonna be sodium hydride. Now sodium hydride, here is hydrogen, right? Now hydrogen is attached with sodium. What is sodium? Sodium is a metal. So we all know sodium has +1, therefore hydrogen is gonna be -1. So that's exactly what we're saying here. This is exactly what we're saying here, all right? So it's just basically understandable, right? If you just know this example, you'll understand it yourself. The other example I'll be giving you is of HCl. Now this is hydrogen, right? And it's attached with a chloride ion. Now chloride ion, this is gonna be -1. So hydrogen will be +1, right? So that's obvious. So here basically we're saying the same thing, that hydrogen is -1 when it's attached with metals like sodium hydride. Similarly, calcium hydride. Now calcium hydride, calcium is 2+, and hydrogen will be -1. Aluminium hydride, aluminium is +3, and your H is gonna be aluminium hydride, so your H is gonna be -1, right? Now, the other example is HCl. So Cl is non-metal, so H is going to be +1. The other is water. So oxygen is non-metal, hydrogen is going to be +1. The other example is ammonia, NH3. N is non-metal, hydrogen is going to be +1, right? This is so simple. So we are done with that. Now let's come and look over the oxidation number of oxygen. Now oxygen has 4 variable oxidation states: -2, -1, -1/2, +2. Now -2, we all are very much familiar with it, but this is the one that will be creating a lot of doubts in your mind. I'll come to all of these one by one. Let's start off with the first one. Now -2. This is basically the normal oxide. Now whenever we look at this, what comes to our mind? Water, right? H2O. So water here +1, right? And then +1 into 2. So oxygen is going to be -2. So all the normal oxides have oxygen as -2, right? Now, -1 is basically peroxide. Example being hydrogen peroxide, H2O2. So here, hydrogen is +1, oxygen will be -1. Simple. This is super simple. Moving on, -1/2. This is superoxide. Example being, it's very important to learn the examples for this, which is KO2, potassium superoxide. Here, K is +1 and O, there are two of them, so -1/2. That's how you get the oxidation number. Now the strange one. Here, what color shall I go with? Okay, right. So you have OF2, oxygen difluoride. Now here basically fluorine is more electronegative than oxygen. So more electronegative usually gets the negative sign, right? So this will get your negative sign. So it's basically one fluoride is -1. There are two of them. So 2 into -1. So that gives you -2. So this will be +2. I hope that makes sense. So there are 4 oxidation states: -2, -1, -1/2, +2. -2, very common, water, normal oxide. -1 is peroxide, hydrogen peroxide. -1/2 is superoxide, potassium superoxide, and +2 is the strange one, oxygen difluoride, where the state is +2 for oxygen. So that's pretty much it. There's a question that's coming up, and that's kind of tricky, but I have a trick for it. So you can look for the next video and you learn how to solve it. I hope today's lecture is clear. We looked into the difference between oxidation and reduction. So oil rig. Oxidation is loss of electrons, oxidation is loss of hydrogen, and oxidation is addition of oxygen, as the name states. Addition of oxygen, therefore addition of electronegative element, therefore removal of electropositive element, and its increase of oxidation number. So we've learned all of these. After that, reduction is basically removal of oxygen, then reduction is rig, gain of hydrogen, gain of electrons. Since it's removal of oxygen, it's removal of electronegative element, it's addition of electropositive element, and it's a decrease of oxidation number, reducing. Then we looked into the oxidation states of hydrogen. -1 is when it comes with metals, because metals tend to be positive, therefore hydrogen will get the -1. And if it comes with non-metals, non-metals tend to be negative, therefore hydrogen will be +1, as easy as it sounds. Then you have oxygen. It has 4 variable states: -2, normal oxide, water; -1, peroxide, hydrogen peroxide; -1/2, superoxide, like potassium superoxide. Then you have +2, as in oxygen difluoride. And that's it.